So if you are going to have a crystal oscillator based on Hartley or Colpitts, so in the for crystal Hartley oscillator, see, Colpitts we have seen C1, C2 crystal we are having. Instead of in the inductor, we are replacing the capacitor. So for crystal Hartley oscillator, I will replace L1 and L2 with the crystals. I will replace the L1 and L2 with the crystal. So the frequency of oscillation is given by 1 by 2 pi root of L1 plus L2 into C. And this L1 is not your inductor. L1 is the inductance provided by crystal oscillator 1. And L2 is the inductance provided by crystal oscillator 2. And C is the usual capacitance what we are going to have in our circuit. So what is the advantage of using crystal oscillator? It is going to have a very, very high quality factor. Since you're going to use a relatively pure crystal, the quality factor is going to be very good. So when the quality factor is good, the bandwidth is low and the selectivity is very good. So it is used for selecting the frequency. That's why it is going to have only one frequency of oscillation, either FS or it is going to be FP. And crystal oscillators are used in applications where there is a very strong demand for the frequency stability, where there is a very strong demand for frequency stability. Frequency stability means whatever conditions your circuit is changing, the frequency of oscillation should be constant. It should not vary. Okay, and also as the usage of component increases, as aging happens, this oscillator should not get disturbed by any of the factors, and the frequency of oscillation should remain essentially a constant value. However, the resonant frequencies are temperature dependent. You know that any semiconductor device affected by temperature, so it is always necessary to enclose the crystal in a temperature controlled oven. So whenever you are going to use a crystal oscillator, ensure that the variation of temperature is highly controlled, or you are going to have almost zero crystal temperature variation for the device, because that is going to affect the frequency of oscillation, which is in turn going to affect all the parameters of the crystal. So if you are going to make your crystal oscillator temperature independent, it is always necessary to have the crystal oscillator inside the temperature controlled oven, so that the frequency stability is 1 in 10 power 10, which means if only for 10 power 10 samples, only one crystal oscillator will change in the frequency because of the varying temperature. Okay, so this is one property which makes crystal oscillator a very popular candidate for real time